Good day everyone. In today's class, we're going to consider topical questions on transformations of functions. So starting with the first question that we have here, f of x is transformed to this function here, 1 plus f of 1 over 2x. Then we should describe, you have to describe the two simple transformations which have been combined to give the resulting transformation. So looking at this now, obviously we have two transformations here. This is translation and this is stretch. Okay, this is vertical translation and this is stretch. So now what you need to remember is that if you have f of a, if f of a transforms to f of ax, we know that the stretch factor here is what? Stretch factor is 1 over a, and that must be parallel to the x-axis. Now for us to have f of 1 over 2 here, it means that the first transformation there is stretch. Okay, we scale factor of 2, and that is parallel to the x-axis. So that's in the first transformation. So the second one is plus 1. Plus 1 here is vertical shift, so which is under translation. So translation by, so since this is vertical shift, we can write that in vector form to be 0, 1. And these are the two transformations that combine together to have this. Okay, so moving to the next question, it's just simple. Now we have another question here. The graph of y equals f of x is transformed to this graph of 3 minus f of x. Describe fully in correct order the two transformations that have been combined. So you should be very careful with this. You have to follow the order, otherwise you not even get your full mark. That's just it. So we said anytime you have something like this, you follow the rule of Bodmer's, Pedmer's, or whatever you know it to be. So that's what you are going to follow. Okay, so you start with reflection. So the first one here is reflection. And what type of reflection is that? If f of x transform to minus f of x, this is reflection in the x-axis. So you have reflection in the x-axis. So second thing that you have here is this constant. This constant here means vertical shift, which is translation. So what type of translation is that? That is translation by vector 0, 3. So that is the right order. So you don't start with translation then followed by reflection. If you start with translation and you follow it by reflection, what that means is, what you are trying to say there is you having minus 3 plus f of x. That's what it means. Because when you translate f of x first, okay, that becomes f of x plus 3. Okay, if you now reflect this, that's going to be minus f of x plus 3. That's why you have to follow the order. So the order should be reflection first before what? Translation. Okay, and I think you still have to repeat it to your textbook if you don't understand this, because we said we have rule for when you are combining two horizontal shifts, two horizontal transformation, two vertical transformation, and when you have one horizontal and one vertical. So you just have to go back to it, but this is the right order for this question. Okay, yeah, moving to the next one. Okay, so the question here, we have two graphs. They say in each part a and b, the graph showing the solid line has equation y equals f of x. So this is y equals f of x. Okay, and the graph shown with broken lines is transformed by y equals f of x. So state in terms of f the sequence of the graph. Now this statement is very important. State in terms of f of x, not to write it out as a statement, but rather in terms of f of x. Now this is the initial function, and you realize that what you have here reflects in the line y, and when this line y is just like a mirror line to this, if you look at it carefully, and you are going to have something like this. If this curve reflects here, sorry, if this shape reflects here, reflects in the line y, you're gonna have this. And reflection in the line y is denoted as what? Y equals f of minus x. Y equals f of minus x. And that's the answer to that. Okay, so to the B part of the question, what exactly are you here to find it? It says state in terms of f the equation of the graph shown with the broken lines. So now to get this, let's study this question carefully. The line here, look at the first one here that we have. This is what we have. Here is the minimum value and here is the maximum value. Okay, it means that this one has, this is just times 2. That's the line there. Now the second one is from here. The minimum point is here and the maximum point is here. So minimum value here is here, maximum is here. So it means that the line here is something like this. The range of that is something like this. Okay, so let's count the boxes we have in between the first one, 1, 2. So we have 2 boxes here, and the second line 1, 2, 3, 4. So we have 4 here. So what's happened here? What can we say about the two graphs or two functions? It means that this is a vertical what's it called, vertical stretch now. Okay, so it's a stretch factor of what? 2, because by the time you multiply this by 2, it's double the what, the result you have here. Okay, so that is stretch factor of 2, and of course this is parallel to the what, to the y-axis. So stretch factor 2 parallel to the y-axis can be written as y equals to f of x. Okay, now see, we have this curve and we have this. Look at the shape that we have there. Sorry, why am I saying curve? So look at the shape that we have here, this polygon here. This shape, it maintains the same posture, just that different position. The same thing, it maintains the same length as this, just different position. And what we are going to do here is that we have two translations here, vertical translation and horizontal translation. Initially this is the minimum. Now let's count this, 1, 2, 3. So it means that you move this curve or this shape 3 units down, then 1, 2, 3, 4, then 4 units to the left. So 3 units down, it means f of x minus 3. So f of x minus 3. Okay, and 4 units to the left, it means f of x plus 4, then minus 3. So the transformation here now is f of x plus 4, then minus 3. Is that okay now? So now next question. The diagram shows graphs with equation f of x and g of x. Describe fully a sequence of two transformations which transform the graph y equals f of x to g of x. Yeah, now when you look at this, the location of this f of x has changed to this place. Before, major part of this diagram is at the right hand side of the graph. Okay, but now major part of it now, everything, in fact everything here is at the left hand side. So the position has changed, and for that to happen, it means that there must be translation, okay, or reflection. But looking at this now, we still maintain the same direction, so that means there must be translation there. However, what we have here now, okay, is more than this. Okay, in terms of vertical measurements. So when you look at the length of this one, here is a minimum and here is a maximum. So let's draw a straight line to know where that starts from. Okay, and the box is say 1, 2, 3, 4, 5, 6. So we have 6 there. This is 6 times 6. And let's check the second one, just from here to down to this place. So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12. the second one is 12, this is times 12. So what happens here? So it means that what you have here is double of this, and it is stretch factor. It is stretch factor parallel to what? Parallel to the y-axis. So stretch factor of what is this? So of course this is going to be stretch factor of 2, because when you multiply 6 times 2, then you're gonna obtain 12. Okay, and having stretch factor of 2 parallel to the y-axis, that can be written as y equals what? I think we have to write it here. They asked us to write it as statements now. So one is stretch factor or stretch parallel to y-axis, then scale factor 2. Now that's the first thing. Then second thing now, like I've said, is the position of the diagram has changed. So this is what we have from here before. When you consider the x value here is 5, okay, while the x value here is -1. Okay, so let's count that. 1, 2, 3, 4, 5, 6. So there is translation of 6 units to the left. 6 units to the left can be represented in terms of vector as translation by -6, -0. Is that taken out? So that's just it. So let's move to the next question, and that's 4 marks. Okay, expect this in form of this, where a, b are constant. Of course, you all know what to do about this. So x squared plus 6x plus 5, this is x plus 3 squared minus 3 squared plus 5. Okay, so x plus 3 squared, this is -9 plus 5, and this will definitely give us x plus 3 squared minus 4, and that's 2 marks. Then b, we are told that the curve with this equation is transformed to this from x squared now to x squared plus 6x plus 5. So describe fully the transformations involved. Now let's write it out. Before, we have it as y equals x squared, and this transforms to y equals x squared plus 6x plus 5. Again, y equals x squared transform to y equals, remember we just obtained that what you have here can be written as this: x plus 3 squared then minus 4. So let's just put that here: x plus 3 squared minus 4. Okay, so the transformations here is that there is vertical shifts, and at the same time there is horizontal shifts. Okay, vertical shift of translation, you can write it as translation of 3 units to the left and 4 units down. Okay, or you can just combine the vector and write as this: translation by -3 minus 4. Is that clear? Okay, so this is the last thing we're going to consider here. The graph f of x is transformed to this. Describe fully the two single transformations which have been combined to give the resulting transformation. So the 2 here is stretch factor, this one here is translation. Okay, so yeah, what are we going to do here? So let's start with translation. The translation there is what? Is 1 unit to the right, but in vector form, just a translation by vector 1, 0. And these two, like I've said, is stretch factor, and that is parallel to the y-axis. So stretch parallel to y-axis. Then we scale factor 2. Okay, so that is that in that regard. So this is where we are going to stop for today. So I will still release some videos on transformations of functions. So don't forget to like, subscribe, and comment. Thank you. Bye.